Hi everybody, this is Mrs. Dinkelman, and this is the second half of the notes for 4.5. And this is about the second derivative test for relative extrema. So normally we use the second derivative test to determine whether something is or a function is concave up or concave down. But it turns out that if we want, or if we have to, we can use the second derivative to determine whether there is a max or a min at a location as well. So it gets a little bit confusing trying to do both. I just want you to know. So my recommendation is always that we just do the first derivative test and do a number line analysis. So if that's safe for you, that's fine. But every once in a while, they will force us to use that second derivative test. So I'll show you what that might look like in the homework if I can find it. So again, Gary says here, it doesn't require that we do a number line. So normally maxes and mins, we would do a number line. The first part of this procedure is the same. We still have to find the critical values or critical numbers from f prime, but then we're going to use those to put into the second derivative. So let's go ahead here on example 7 and take the derivative. And we would set that equal to 0. So I'm going to factor out a 12x here, do a negative 12x. So it looks to me like our critical values are 0, and I know I could factor that some more, but rather than do that, I just know that I can identify 0, positive, and negative 1 there. Okay, so first derivative test. This is if we would want to do it. What we would normally do is we would do a number line, and we would do our analysis on the number line. Let's do that afterwards just to verify that what we do next is correct. So what we're going to do actually for the second derivative test is take those critical values from the first derivative and plug them into the second derivative. So let's find the second derivative here real fast. Okay, so negative 36x squared plus 12. So what I'm going to do is I'm going to figure out what f double prime of 0 is, f double prime of 1, and f double prime of negative 1. And the truth of the matter here is I really only want to know if it's negative or positive. So if the numbers are too large, you don't have to worry too much about finding the number, just whether it's positive versus negative. So if I plug a 0 in, I get 12. If I plug a 1 in, I'm going to get negative 24. If I plug in, or sorry, positive 1. If I plug a negative 1, I'll get negative 24. Okay, so remember what the second derivative tells me is about concavity. So I know right here, this is concave up, this one is concave down, this one is concave down. The other thing I know is that the first derivative is 0. So on this one, we're literally talking about that spot right there. That means that this is a local min. Again, I know this is concave down. I know the derivative, first derivative is 0. So we're talking about that spot literally right there. So that's a local max. And then same for this next one. That would also be a local max. Now, as a student, this felt a little backwards to me because I got a positive out of the second derivative, which meant I got a local min. So I spent a lot of time drawing the picture to make sure I understand that when I have a positive second derivative and it's a candidate for a min or max, that would be a min. Again, the alternative is just to go back to what we did before, where we would just analyze the derivative. So remember, we would take like a negative 2 and we would plug it into this derivative. So I would get a positive on the outside here and a positive on the inside. If I plug in like negative a half, that'd be a positive, negative, positive a half, negative, negative. Let's say like a 3, negative, positive. And so I could identify right here, there's a local max. So max there. And then this one, negative to positive, that would be a min. Okay, so we got the same result, just doing it a different way, but we can use that second derivative. This feels like a little more plug and chug as opposed to analyzing, so it just kind of depends on what you prefer. Let's go ahead and look at the next example. Okay, so some derivative values are shown. We want to look for the relative min and max where possible. So the first thing I would want to identify is where the derivative is equal to 0 or undefined. So let's look in this column first and see what the critical values could be. So -3, -1, 0, and 2. All of those have the first derivative being 0. So let's figure out what's happening with the second derivative. So this is kind of an example where it would force us to use the second derivative because we couldn't do a number line. We don't know what's happening on the in-betweens here, so we wouldn't necessarily be able to figure that out. Okay, so let's figure out the second derivative at each of those locations, and then we'll see if we have to do any more work after that. So g double prime of -3 is 4. Again, that's a positive, so it means we have something that's concave up. So that means we have a local max here. Local max. Spelling's a problem sometimes. Okay. At -1, we have -1, so that means we have something that's concave down. That means we'd have a local, oh my word, come back here. So again, let's draw the picture over here. Concave up, that's a local min. Concave down, that's a local max. See, I always have to draw the picture. Okay, at 0, we have 0. So we might have to do a little bit more thinking here. Let's just put a question mark here and come back and look at that because we don't know for sure what's happening there. Not yet, at least. Okay, at 2, we get 3. So again, that's something that's concave up. That would be a local min. Okay, let's come back and look at this one with the question mark just to see if there's anything else we could do to figure out if it's changing anywhere in there. So we definitely know that it's a candidate. We don't really know if the derivative is changing from a positive to a negative or vice versa here. It's really tough to tell. So there's no extra information that would help us be able to. So right now we just don't have enough information to solve that one. Okay. So let's look at the assignment a little bit. I'm going to have to I only have one page of it, but let's look just a little bit at it. So 10 says use the second derivative test to find the relative extrema. So you decide on those. Honestly, you would be able to just make that decision on the AP exam, whether you would want to do a number line or whether you would want to do the second derivative test. So I'll let you decide on that one. And then let's look at, just go find another copy of, I feel like there's definitely one or two in here that force us to use. So let me just look at the next page and see if there's more that where they force us to use it. So kind of 13 is forcing us to do it a little bit or to think about it. Same with so 13 and 14, because for instance, we know that the derivative is 0 at all of these locations. And then what they give us next is the second derivative. So they're definitely going to force us to use the second derivative there. And then I was trying to see if there was an implicit one where they make us use that second derivative test. And I'm not seeing one. We'll definitely have to practice one to see if there's any more. Looks like that's it. So we'll definitely have to practice an implicit one with the second derivative test. I'm going to go ahead and talk about 13 if you would like me to, just to do that one, and then you can get to the assignment. If you already feel like you got this second derivative test under control, then go ahead and turn it off and get going. So what I want to do is just decide what's happening at each of these critical values. So right here we have the second derivative being negative, so concave down. That means we have a local max. This one at 1, we don't know what's happening, so that's kind of like we need more information to be able to decide that. And this one, the second derivative is positive, so we know we have something concave up, so that's a local min. Okay, so go ahead and try to work through the rest of that assignment and finish it. Come with questions tomorrow so that we can go over anything that you want to go over there. And like I said, we'll definitely practice doing that second derivative test with an implicit because that's where I normally see it on the AP exam.